Hello class, this is the continuation of our topic for the last discussion about redox titration. So in the last discussion or lecture, we discussed about the balancing of the redox or oxidation reaction in acidic solution and basic solution. Now, punta na tayo doon sa may ating redox titration. Okay. Sa may redox titration, guys, usually in a typical volumetric analysis or titration, itong kadalasang setup, we have this titrand here. Suppose that this is a burette, kasi hindi ako magaling mag-drawing. Okay? So suppose this is a burette. Typical setups in a redox titration. This is a burette. And this is the Erlenmeyer flask. Yan. So this one here, usually, dito na-allocate yung titrand. And this one here, yung solution na tinatitrate, is yung ating titrand. This is the typical setup for the every titration. But in redox titration, guys, di ba? Sa ating neutralization titration, di ba? Ang titrand, it can be either on acid or yung titrand natin, it can be either acid or on base. Basta importante, magkakaroon ng neutralization reaction. But here, in the our pa natin, hindi tapat. Basta ganyan, tatapat yan. Okay, in the redox reaction, it's either the titrand is a reducing agent, ayan, a reducing or oxidizing agent. Ayan. Kapag naman yung titrand natin is kapag reducing agent yung titrand, syempre, ang nasa titrand natin is oxidizing agent. And kapag oxidizing agent ang yung nasa titrand, yung titrand natin is reducing agent naman. So, dapat magka-opposite in order for the reactions to occur. Hindi pwedeng reducing to, tas reducing to. So, walang mangyayaring dito. Walang mangyayaring reactions doon. Okay, and then the other one here is, you could recall the indicator, which is an indicator to indicate the equivalence point. Equivalence point of the reaction natin na kung saan yung moles nung natin ng reducing agent ay equal na sa moles ng oxidizing agent. Ayan, sinorted ko lang po susulat, guys. Ayan, i-indiko natin sa ating neutralization titration ng acids of base. Ang ginagamit natin is yung phenolphthalein, right? Which is phenolphthalein ay colorless. And then, ang kanyang equivalence point number ay ang equivalence point color niya is faint pink. Ayan. And then kapag overshoot, kapag sobra-sobra na yung na-add natin titrant or the sodium hydroxide, ang kulay niya is pink na. So dark pink. So ibig sabihin, ulit yan. So ganun lang din dito sa may ating redox titration. You have to achieve the specific color for the equivalence point. Kapag sumasobra na yung titrant, yung kulay is either nagda-dark or nagko-colorless. So, ganun lang din yung magiging reactions natin dito in the typical redox titration. Okay, so what are the components? The titrant, and the indicator. So, in this discussion, guys, I want to discuss ang magiging discussion natin is for the indicate the natin is reagents used in the redox titration. So, the titrant, we are talking about the titrant and the titrant itself for used for the analysis, the reducing agents and the oxidizing agents and their corresponding indicators. Okay. Pero punta muna tayo dito. The indicators used in redox titration usually is a starch by which ginagamit siya sa may ating iodometric titration, which is a type of oxidation reagents. And then the other one here is the potassium permanganate. Potassium permanganate is an indicator itself because it is a strong oxidizing agent. Siyempre, kapag strong oxidizing agent siya ay mare-reduced into manganese. Ayan, no? The permanganate ion is highly colored, while its reduction product is manganese ion is colorless. So, hindi mo na kailangan maglagay ng indicator. Pero dito sa ating iodometric titration, kailangan mo ng starch as the indicator. And by the way, this one here is used as a permanganometry. Yan. So those are the indicators the titrants and the titrants. Ayan o. A volumetric analysis that relies on the net change. Ayan, the redox titration, its definition. Ayan. Okay. Ayan o. Both oxidation or reduction occurs during the titration. Okay. So before we proceed in the redox titration, kailangan ang una ninyo gawin is the sample preparation. So it is the pre-treatment process. So ano bang nangyayari dyan, sir? Bakit po namin kailangan ng sample preparation? Okay. Actually, sa may neutralization titration, meron din kayong sample preparation. When in standardizing the sodium hydroxide, you have to heat or oven dry the KHP at 60 to 100 yata degrees Celsius. I can't recall. Basta ang goal doon is to remove the moisture from the KHP kasi nga siya ay hygroscopic which can absorb water from the environment. Dito naman sa atin is, let's say we have the titrant again. Ayan. And you have the titrand. Ito yung titignan nyo guys, the sample preparation. Yung nangyayari sa may titrand ninyo, which is our sample. Ngayon, ang kailangan ninyong gawin, kasi let's say suppose we are performing a serimetry. Serimetry, which is ito yung cerium here or yan. The typical setup or serimetry is ito nandito. Ayan, this is the typical setup for the serimetry. Ayan, which involves the redox titration of our iron and cerium 4. Ayan, ayan, nakikita nyo naman. Ayan, sample preparation. Okay, meron pa ng example. Okay. Okay, ang gagawin niyo is sample dissolution in a suitable solvent. Pero ang mangyayari doon kasi guys, when you do that, ang mangyayari doon, let's say FeCl3. Merong kasing tendency na ito ay may halong hindi lang basta ferric ion. Meron din tayong ferrous ion which can result in or other sample, let's say water sample. Okay, water sample yung tinatreat ninyo. And you want to determine the ferric ion. Ano ba yung nasa example dito? Ayan, you want to determine the ferrous ion. Pero hindi may iwasan na meron tayong multiple oxidation state of our analyte or the sample of interest na ina-analyze natin. So we have to remove the ferric ion to isolate para matira lamang yung ating ferrous ion. So, how do we do that? Kasi nga, magkakaroon ng interference to sa ating titration which results to an error to our obtained result after the analysis. So, anong gagawin natin? Ayan. You have to use the pre-adjustment of the analyte oxidation state. Gagamit ka ng reductant when you are trying to oxidize. Ngayon, kapag naman kunwari, gagamit ka dito, let's say you want the present sample in the analysis is Fe3 positive and Fe2 positive. And you want only Fe2 positive. So, gagamitin mo dito is, gagamit ka ng mga reductant. So, ano ba yung ginagamit doon? These are the list. We have the stannous chloride, we have the chromous chloride, Jones reduction, and Walden reductor for the pre-reduction. What if naman suppose that you want only, ang ina-analyze mo lang, is yung ating ferric ion instead of ferrous ion. So, ang gagawin mo dito is i-oxidize mo siya. Gagamit ka ngayon ng oxidant or pwede ka magkakaroon ng process ng pre-oxidation process. So, ano ba yung nangyayari doon? Peroxydisulfate, sodium bismutate, hydrogen peroxide. But the point here, guys, is you have, kailangan ninyo, only one oxidation state of the analyte lamang ang present bago kayo mag-analyze. So, that's the sample preparation. Okay? And these are the Jones reductor. This is a typical reaction. It's composed of zinc amalgam. So, mangyari ito is, you have this analyte solution. Tandaan dito kung sa may burette na to. And then, this here, we have tayong solid reductant that will reduce for the pre-reduction to or kung kapag naman ating pre-oxidation, ito ay solid oxidant. Ayan. So, dadaan siya dito, yung solution, and then sintered glass, and then you will have the reduced analyte or the oxidized analyte na. So, ganon. Dadaan siya dito bago mo ilagay dito sa ating Erlenmeyer flask before performing the redox titration. Okay? So, ganyan. And hindi kasi natin yan magpa-perform since hindi face-to-face classes. Pero, I'm just discussing the theories. Okay. So, ayan, these are the uses of Walden reductors. Ito yung mga nire-reduce niya. The Jones reductor. Ayan, yung mga nire-reduce. These are the list. And as you can see here, the electrons are on the reactant side. Kaya, yun yung proof. Okay, next naman natin is yung ating oxidizing and reducing agents. Wait lang, nag-jam yung internet. Ayan. Wait lang, guys. Okay, let's continue. Okay, oxidizing and reducing agent. These are the oxidants and these are the reductants na ginagamit nyo for the preparation process of your sample. The preparation process of your sample. So these are the reductants and these are the oxidants that you will use. Ayan. So punta na tayo ngayon, reagents used in the redox titration. We have the reducing agents and the oxidizing agent. And I will make this quick day kasi it's just more on theories naman. So maboboringan kayo sa ating discussion. So the other part will be your reading assignment. Okay? Sige. So the reducing agents in this case are included the ferrosalt, sodium disulfide pentahydrate, arsenic trioxide or arsenious oxide, sodium oxalate and oxalic acid dihydrate, titanium trichloride, and potassium ferricyanide. So these are the reducing agents used in the redox titration. Ito yung mga reducing agents natin na ginagamit. Also known more salt. So ayan. And then sa ating sodium thiosulfate, here, the reducing agents, the thiosulfate ion is a moderately strong reducing agent and it is widely used to determine the oxidizing agents by an indirect residue that involves. So this is the typical reaction of the sodium thiosulfate with this iodine as an intermediate here. Ayan, so these are the typical reaction. And then ang application ng ating sodium thiosulfate reducing agent is to determine the hypochlorite in bleaches. So magkakaroon ka ng redox titration, yun yung bleaches yung sample mo, and you will use the titrant sodium thiosulfate to determine the amount of the hypochlorite in bleaches. And then your indicator is the soluble starch or the beta amylose. So ito yung reactions natin. And just some sort of succeeding calculation using the moles equals na. Mamaya is itatakil natin sa ating sample problem. So the standardization, okay, before you conduct the analysis for the hypochlorite ditches, the sodium thiosulfate must be standardized before you conduct the analysis. And what is the primary standard solution to be used to standardize the thiosulfate solution? You will use a potassium iodate or potassium dichromate or potassium bromate. And these are the titration reactions for the analysis. Ayan. So titrant mo is the thiosulfate, the titrant either potassium iodate, potassium dichromate, or potassium bromate. And then these are the titration reactions. And then ito lang yung gagawin niyo on the 6 equivalent succeeding calculations for the calculation of normality. Ito yung formula natin for the normality of our sodium thiosulfate. Ayan. So weight nung ating oxidant, and then one normality, usually one normality, then liter, and then the molecular weight. Terms of milliliters. So those are the titration reactions. So the calculations here are here. Kung mapapansin niyo, the equivalent weight, ayan, when using a calculations, and kung mapapansin niyo, ang tinitingnan dito, as you can see from the divisor, ang tinitingnan niyo is yung number of electrons. Okay? So, paano ba yan? Ito yung formula natin ang pagka-connect natin. So, first and foremost, the equivalent weight. Ang kanyan is yung formula weight, which is given naman sa periodic table, and the number of electron change na kung saan makikita dun sa ating reactions. For the iron, 1 electron, so negative 1 yung divisor. For the potassium permanganate, so 5. And then sodium thiosulfate pentahydrate, ayan, so 1. And then for the dichromate ion is 6. Ang point ko dito is the divisor is the number of electron. Now, dito magra-rise ng ating equivalence. Na kung saan gram all over equivalent weight. Na kung saan yung equivalent weight can be extended further to gram all over formula weight all over electrons. And then let's simplify the equation. Ayan, the electron or the equivalent electron change all over the formula weight. Ayan. So those are the formula of equivalent. Now, punta na tayo sa may normality. Normality daw is equals to equivalent per liter. Ano ba yung expanded form ng equivalent natin? Equivalent per liter is just a grams times electron all over formula weight. Ayan, formula weight all over formula weight all over liter. Ayan, so ibaba lang natin. So grams times number of electron change, formula weight times liter. So this is the formula for our normality. And ang pinaka-crucial dito is yung number ng electron change natin na kung saan makukuha ninyo through balancing the redox reaction. Ayan, so yan yung pinaka-crucial. So you have to know first how to balance the redox reaction before proceeding in a redox titration. Kasi napaka-crucial niya. Yan. Ayan, calculations, some applications of the sodium thiosulfate as a reductant. So these are the analysis, yung mga analyte na pwede niya i-analyze using sodium thiosulfate as our titrant with specific or special conditions. Ayan. So these are the list. And then, punta naman tayo sa ating reagents used in the redox titration. So we're done with the reducing agents. Punta naman tayo sa may oxidizing agents. So there are 7 oxidizing agents na ginagamit sa ating redox titration. And those are the potassium permanganate, potassium dichromate, iodine, potassium iodate, potassium bromate, sodium nitrate, and calcium hypochlorite. Okay. Isa-isahin natin hanggang dito sa may promatimetry. Ayan. From permanganometry to promatimetry. So these are the common oxidants used. Ito, these are the standard solutions. Pwede ninyong, ito yung natin, standard solutions na ginagamit ninyo to standardize the solution. Kasi nga, before you use the titrant, you have to standardize it. Kasi nga, may mga impurities tayong present, so we have to determine the exact concentration of that. Okay, yun yung laging natandaan niya. When performing a titration, you have to standardize the titrant to be used before analyzing the analyte. Okay, so the reagent here is the potassium permanganate. You have to standardize it with sodium oxalate, iron, or arsenic trioxide. And indicator nyo is manganate itself, so it will serve as a self-indicator. Ayan, so potassium bromate, ito, standardized with potassium bromate din. Ayan, makikita ninyo dito here. And then indicator is ito yung nandito, alpha-naptocarbone, 1, 2, 3. And then cerium standardized with iron or arsenic trioxide. So number 2, phenanthroline, iron 2 complex or terwin, yung indicator ninyo. And then so and so forth. Ayan. So those are these. And then sa stability, you have to consider this. Ayan. Stability nila ay ito. So here. Yan. So those are the list na kailangan ninyong. And you don't have to memorize those naman. Kung gusto nyo memorize, sige, go lang. So unahin natin is the permanganate titration. Okay. Siyempre, it is an oxidation. Since it is an oxidation, it is an oxidizing agent. In the product, marireduce siya. So marireduce siya into reduction of permanganate, which the reduced form of our permanganate is the manganese 2 ion from violet to colorless. So it is a self-indicator. So ang end point ng ating permanganometry titration is a faint violet dapat. Kasi nga colorless, that is an overshoot. Ayan. So yun yung ating panatin. Ayan. Colorless manganese. Or parang sa pagka-recall ko na nag-perform kami is parang pag nag-imagine color. And ayun, i-ko na lang. I-discuss ko na lang later kapag na-recall. Ayan. So in acidic neutral, these are the reactions. Here, in a very strong alkaline. So this is the reactions. Ayan. These are the reaction and these are the reaction. In the acidic neutral or alkaline solutions, ayan, in a very strong alkaline solutions, ito yung natin. So green manganate ang ma-generate natin instead na colorless. So here, the standardization of our potassium permanganate, as discussed earlier, is pwede niyo siyang standardize with sodium oxalate with the self-indicator na potassium permanganate. Kasi nga, ba't kaya ganun? Kasi nga meron tayong traces ng manganese 4 oxide na present. So you have to remove that. I have to standardize this to determine the exact concentration of the potassium permanganate. So standardization with sodium oxalate. Paano lang yan? Sa neutralization titration natin, sodium oxide is the KHP, and then yung ating potassium permanganate, ito yung ating sodium hydroxide. Ayan, so this is the reactions. Further calculations, so 10 equivalents, ayan, 2/5 to, and then you will get the answer. So these are the applications of the permanganate titrations to be analyzed. So we have the species analysis na ferrous ion, oxalic acid, bromide, hydrogen peroxide, and so on and so forth. So yun yung ina-analyze niya. When performing a classical analysis involving a permanganate titration for the determination of the concentration of the species analyzed. And these are here. The next natin is the applications here. Ayan, these are the reactions. Yan, when you are analyzing the permanganate, these are the reactions. So the number of electrons involved is makita nyo naman dito sa may table na ibigay ko. Upload ko later. Here, span. Yan, dito. So ayan, yan. Next naman natin is oxidation with cerium or serimetry. Ang indicator na ginagamit ito, siyempre iti-titrate natin, ang indicator is the ferrowin or diphenylamine. When you want to standardize this, gagamit kayo ng mga ito. Ammonium, hexa, nitrato, seri. Ito yung mga. So it is a primary standard grade when you want to standardize the cerium. So ito yung nag-act as KHP niya. And then ito rin yung other one here. Pwede rin natin kuha natin. Ayan. Standardized with sodium oxalate. Pwede rin. So here. So these are the applications of the serimetry. Ito yung mga ina-analyze niya as a titrant. Yan. Siyempre, preparation or pre-oxidation or pre-reduction muna ang gagawin niyo for the sample preparation. Okay? Pre-treatment process muna. So application of serimetry, these are the reactions here. Those are the list. Ayan, kung explain ko pa kasi isa-isa, this discussion will be boring. Ayan, for the iron, these are the reactions. And then third is oxidation with potassium dichromate or dichrometry. Ayan, these are the reactions or balance oxidation pa natin. Ayan. So potassium dichromate is a primary standard. An indicator na ginamit is diphenylamine sulfonic acid. Ayan. So ayan, these are the kuha natin for the redox titration. Dichromate standard solution. Ayan. So very large complete reaction occurs sa nangyari between our hydroquinone for the analysis of hydroquinone and your titrant dichromate standard solution. Ayan. So next naman is iodimetry or iodometry. Sa iodimetry, ang dapat pa ninyo is iodimetry is an oxidizing agent. So you must have a reducing analyte to directly titrated with iodine. Ayan. Then sa iodometry naman, oxidizing analyte. So therefore, ito ay oxidizing agent. To excess iodide, ayan, so we would produce and then titrated with standard thiosulfate solution. So this is the reaction for the complexation of the iodide. So ang indicator ninyo is the starch. The disappearance of those starch, so dapat is pink blue ang makakalabasan niyan. Ayan, the disappearance of those starch indicates the endpoint of the titration. So dapat ma-measure niya na agad at the start of the disappearance of the blue starch color. Yun na yung endpoint niya. Kaya dapat you can assume na yun may excess. Kaya dapat dadaan muna kayo sa may faint blue to determine actually the disappearance of blue starch. Hindi pwedeng directly na the disappearance agad. Magkakaroon kayo ng error dyan. Baka na-overshoot kayo. Doon kayo magkakaroon ng error. And these are the species analyzed of our iodimetry and iodometry. And these are the species analyzed. So this will be your analyte here. Yan, the reactions and their corresponding reactions. Ayan, the corresponding reactions here. Ang dami. You don't have to memorize this, guys, kasi ginawa na siya ng mga mga scientists, chemists natin. Sila na gumawa. Yan, these are the applications again for the iodine solutions. Substance to be determined and their half reactions. So last one is the promatimetry. The promatimetry, ito naman, ang oxidizing agent na ginagamit natin is potassium bromate. These are the reactions. Ayan. When mixed with iodine, ito yung reaction niya. Ayan. And then substitution reactions will occur. Ito yung mangyayari. Ayan, sulfanilamide, then bromine ion. Ayan. These are the reactions here. And that's the last. Ayan. For the oxidation and reduction equivalent, the easiest way to find the equivalent of an oxidizing or reducing agent, na-discuss ko naman na ito kanina. Sa ko ba yung na-discuss? Sir, saan niyo po yung na-discuss? Dito sa may part na to. Ayan, dito sa may part na to. And kung i-repeat ko pa, mas maguluhan kayo. The point is to get the equivalent weight, again, is to determine the number of electrons present in the redox titration of the balance, oxidation, or reduction reaction. Ganyan, to determine the equivalent weight. Ayan, equivalent weight, citric acid, when used as an acid. And by the way, kapag acid, nakadepende naman yon sa may number ng hydrogen ions. Kapag H2SO4, siya ay 2. Kapag phosphoric acid or H3PO4, that is 3. Ayan. These are the reactions. Kapag as an acid to, kapag as an acid. Kapag ginamit mo siya as an oxidizing agent, ayan, ito yung magiging reactions natin. So, the equivalent weight will be 3 negative. So, ba't ganun? Ba't ang gulo nyo kanina? Kasi nga, guys, ginagamit yan kapag acid lang, kapag itself to determine the normality. But when you use it as an titrant, as an oxidizing agent, de-determine nyo na yung electrons. Ayan. Oxidizing agent. So, here. And we have the sample problems na i-discuss natin to the next part of our lecture. So, thank you for listening, guys. And I hope you learned something this discussion kahit pinahapyawan ko lang yung discussion. And yeah, thank you for listening, guys, and goodbye.